Okay, this is the 8 a.m. Zoom meeting, January 29th for Math 1113, and we have a participant. Someone came out early this morning, Miss Sandoval. Can you hear me? Your mic looks muted to me. Can you hear me?
Yes, sir.
Okay. Did you have any questions this morning?
Yes, sir. I did have a couple.
Okay, sure thing. What can we help you with?
Okay, and the textbook practice questions for 4.5,
Okay.
I was having a little trouble with 31, 33, and 35, but they're all the same kind of question.
Okay. So this is off page 404?
Yes, sir.
31, solve 4 to the x plus 2 to the 1 plus 2x equals 50. So I'll put the book up so everybody can see page 404, 31. Okay. I'm going to have a few steps in this one. We're going to have to get the same base number over here. And you could write 2 as a 4, but it's a square root. That really reduces a fraction. So better to go with 2 here, meaning 4 is 2 squared. X plus 2, 1 plus 2x, 2 to the 1 plus 2x equals 50.
Okay.
And then you can raise that to the power 2 to the 2x plus 2 to the 2x. Well, I'll keep it 1 plus 2x equals 50. Now here's where we're going to have a little trick of algebra you may or may not be used to. Do you realize I can write 2 to the 1 plus 2x as 2 to the 1 times 2 to the 2x? Is that obvious?
Yes,
or
sir.
do I? Okay, so that's obvious?
Yes, sir.
Okay, so that's 2 to the 2x plus 2 to the 1 times 2 to the 2x equals 50.
Okay.
Yeah, that makes 2 to the 2x a common factor.
Mm-hmm.
One plus 2. Or in effect, one of these 2 to the 2x's time plus 2 of them is 3 of them. There's your 3 there. Maybe I should have shown it that way. In other words, this is a common factor. You come down with 3
Okay.
times 2 to the 2x equals 50.
Mm-hmm.
We pause, let you catch up? Or?
No, I think I got it.
Okay. Well, now getting this 2 to the 2x by itself is basically 50 divided by 3. In effect, you divide by 3, divide by 3.
Right.
And now, yeah, I could do a log base too, but I don't like that. I tried to get that across in the videos. I like to use ln. So ln of 2 to the 2x equals ln of 50 divided by 3.
Okay.
But then that puts the 2x to the front. 2x ln of 2 equals ln. I'll put the 50 over 3 in parentheses. And there's just one final move. Divide by the coefficient. Yeah, the 2 and the ln of 2 are just a coefficient. So you
Right.
divide by them. And so I wind up with this exact answer in ln of 50 over 3 over 2 ln of 2. I doubt that's the answer the book got for the exact answer. But we should be able to punch it out and get the approximation, same approximation they get.
Right. Okay. That makes sense.
You want to see it punched out?
Sure.
Okay. So ln 50 divided by 3, divided by, you'll have a parentheses, 2 ln of 2. 2.0294.
Okay. I understand that. Thank you.
Should we look it up?
I'm looking at the ebook of the version of the textbook right now, and it has both of those answers. So.
Oh, does it look exactly like this?
Yes, sir.
Oh, it's a miracle. Okay, first problem, 1 for 1. 8 in the morning. It's a miracle. You've just witnessed a miracle. Are we going too fast?
No, sir.
Okay. So are we ready for 33?
Yes.
Okay. 33, a little more straightforward. 5 to the x equals 4 to the x plus 1. I wants to freeze this morning. Okay. And again, I'm just going to use ln. You could, use a log base 5. You have to use one here and, or a log base 4 on both sides. But I just stick to ln every time. That puts the x in front, the x plus 1 in front. I need to put it in parentheses because it does distribute. 4, ln, my fault, ln of 4. All right, now at this point, this is your choice. You can go ahead and stick the decimals in. If you want the exact, I don't really make people get the exact answer on something like this. It's a bit of a royal pit to get the exact answer. I usually just divide by the log 5. Yeah. Your cancels here. And then just go ahead and get a decimal here. That gives you just one nasty decimal to mess with. ln of 4, ln of 5, 0.8614, we'll call it. All right, now it's pretty straightforward algebra. We're going to distribute this through 614x plus 0.8614. Then we need to move the x terms over, so we subtract 0.8614x. This is 1x when you punch it. If you don't want to do that arithmetic in your head, nasty subtract problem. It's 1 minus 0.8614, 0.1386x. Oops, a little glare on the screen. 0.1386x. 614. And finally, just divide by the coefficient. Divide by 0.1386. 6.215. That could be a little off of the book, depending on how they rounded. But it should be close.
Yes, sir, it is.
All right. I wouldn't make you get the exact answer. It's a royal pit to get the exact answer. You got to leave this alone, distribute it through, then you got to bring it over, factor out the x. It's kind of a royal pain.
Yes, sir.
Exact answer, so we wouldn't mess with that on that one. And so 35 is similar. You want to see it?
Yes, sir.
Okay. These go in the category, they look so easy when I do them?
Yes, sir. I think I get it now. I was just a little confused going into them.
Sure, no problem. 2 to the 3x plus 1. This is still off page 404. 3 to the x minus 2. And again, same idea. ln both sides, exponents to the front. Usually divide by the ln on this side, move it over to create one nasty decimal. Looks like it'd be a log 2 divided by log 3, and then just follow the algebra. So ln of 2 to the 3x plus 1 is equal to ln of 3 to the x minus 2. 3x, you got two pieces in both these exponents, so they got to go in parentheses. And yeah, you could turn these to nasty decimals and distribute them through on both sides and just play x's to the left. It works. I just prefer to get one nasty decimal. Well, at least 3x plus 1 is equal to x minus 2, and then ln 3 divided by ln 2. Yeah, you got to make sure you close that parentheses over that ln 3.
Right.
1.58496. You want to call it 585? 5. And so, yeah, now it's a matter of distributing this. 1.585x minus whatever 1.585 times 2 is, 3.17. So we're gonna, can you do both things at once? Subtract the 1.585x over and then subtract the 1 over?
Yes, sir.
Okay, kind of both at once, or you can do it separately. 585x, and you subtract the 1, subtract the 1. So let's see, 3 minus 1.585 comes up 1.415x. And then the subtractive here is pretty easy because it's whole number play. That'll be just negative 4.17. These will have canceled, these will have canceled. And final move, divide by the coefficient. Negative 4.17, 41 point, watch the punching, negative, I've punched 41.7. 4.17 divide by 1.415. Negative 2.947. The beauty of these problems is that you don't have to worry about illegal numbers. I don't know if we got that across to you. There's no worry about illegal numbers.
Oh.
Every answer you get is perfectly legal because this could be punched back in up here and you get the same number on both sides within round off error. That's
Okay.
not, yeah, that's not true on logs. I don't know if we got that across. You come over to these log equations, and it's very common that you'll get multiple answers. Some answers will turn these logs either 0 or negative, and you've got to reject those answers.
Right. Okay.
Use answers that keep your logs positive.
Gotcha.
I don't know if you want any examples of that, but
I think I got it at this point.
okay.
Well, thank you for your help.
Well, sure thing. Is that all you need to see?
Yes, sir.
Well, all right. Yeah, you don't want to hang around, no problem. I'm going to hang around at least another 15 minutes and maybe work some more log equations.
Okay. Have a nice day, sir.
Thank you, and I appreciate you coming out.
Thank you, sir.
Mm-hmm. Yeah, we'll go ahead and keep working some more problems. Let's see, I think I did 49 and 50 maybe last time. So why don't we try 51? So this is still off page 404, 51. Solve 2 log x log 2 plus log 3x minus 4. Again, you can't spot the illegal numbers at the beginning. Any illegal numbers at the start, like you could with fractions. But you got to watch for them. All right, we're going to use law 3 here. Use law 3, meaning the 2 goes up, log squared, and over here we're going to combine. These will multiply log of 2 times 3x minus 4. We're going to use base 10. To the log of x squared equals 10 to the log of 2 times 3x minus 4. X squared equals 2 times 3x minus 4. 10 logs will cancel. Oops, close. So then x squared equals 6x minus 8. Bring the terms over, and x squared minus 6x add 8 equals 0. So that's going to give us an x minus 4 and an x minus 2. Negative 4 plus negative 2 is negative 6. Negative 4 times negative 2 is positive 8, giving us x equals 4 and x equals 2. And doggone, I think those are both going to be legal. This is one cooked where both answers work, meaning both answers, 4 there, 3 times 4 is 12, yep, positive there, and 2 there, and 6 minus 4 is 2 there. Yes, both legal. They give positive logs. The original equation. So yeah, while it's very common one works and one doesn't, it's not an absolute law, not an absolute rule. This one, both of them worked. I'm sure you can make one up where neither one worked. Although I don't think I've ever seen that. How about 52? We'll just work our way down. Page 404, 52. ln of an x minus 1/2 plus log 2 equals 2 log x. So once again, we're going to combine and law 3 here. ln of 2 times x minus 1/2. I only wrote the 2. These two multiply. I just wrote the 2 in front because you're used to when you distribute, do that. And over here, ln of x squared. And now we're going to use base e. E to the ln of 2x minus 1/2 is equal to e to the ln of x squared. I'll go ahead and distribute here, saves a step. 2x minus 1 is then equal to x squared. I think I'll switch it. X squared is equal to 2x minus 1, just because we're used to x squareds being on the left. So then that makes x squared minus 2x add 1 equals 0. I think you're going to find that that's x minus 1 and x minus 1. I could write it x minus 1 squared, but you don't really have to. You're going to get x equals 1 out of both, so you only have to write it once. And let's see, log of 1 is 0. Yeah, that's a positive log there, and 1 minus a half is positive. This is legal. All right, coming up with a lot of legal answers on these. 53 looks a little longer. The base 2. Base 2 of 3 plus log base 2 of x. Log base 2 of 5 plus log base 2 of x minus 3. We're going to combine on both sides on this one. I'll give you a log base 2 of 3x, log base 2 of 5 times x minus 3. And we're going to use base 2 2 to the log base 2 of 3x is equal to 2 to the log base 2 of 5 times x minus 3. Oh, yeah. Does he saw 3x is then equal to 5 times x minus 3. This one doesn't have squares, letters, and numbers. Is equal to 5x minus 8. 15. Golly, early in the morning. My apologies. Had it still. Idiot. My fault. Okay, minus 15. Negative 2x equals negative 15. Looks like we're going to come up with a positive 15 halves, or 7.5, 7.5. Either one. That's positive there, and 7.5 minus 3 is positive. Legal. Why don't I take the time to look that one up? I haven't been looking them up. 7 point. Wow, this is still page 404. 7.553. Doggone it. 4.553. 4.553. Okay. Glad I checked 53. I miscopied it. I put an x minus 3 instead of an x minus 2. Log base 2 of 3 plus log base 2 of x equals log base 2 of 5 plus log base 2 of x minus 2. We will not put the recording of this class today. We will not enter it into the Teaching Hall of Fame. I miscopied. My apologies. Glad I checked this one. I hope I've been doing the other ones right. Maybe I should double check those. So yeah, same idea. Log base 2 of 3x is equal to log base 2 of 5 times x minus 2. How embarrassing. My apologies. 2 to the log base 2 of 3x is equal to 2 to the log base 2 of 5 times x minus 2. These cancel. equals 5x minus 10. Should have had 10 there instead of 15. Negative 2x is then equal to negative 10, and x equals 5. And yeah, if you look at the back of the book, that's what they have there. 4.5. Oops. 4.5. Problem 53. Five, yeah. While I'm here, I should probably check the others. So let's see, what did I get? For 52, what's my way back? No, that's the wrong answer for 53. 52, I got 1. Yes. Thank goodness. For 51, did I work 51? I think I did. Maybe not. Yes, I did. 4 and 2. Yes. It'll clear up. 51, 2, and 4. Yeah, I don't think I worked more. Yeah. All right, let's try one more. Oh, I've blown one today. Let's try one more. Correct. 54. Oh, this looks like a long one. 54. Log base 4 of x plus 2. Log base 4 of 3. Log base 4 of 5. Writing too big to get all on one line. Plus log base 2x minus 3. So we're going to combine, and we will get log base 4. 3 times x plus 2 is equal to log base 4 of 5, 2x minus 3. Use base 4. Log base 4 of 3 times x plus 2 equals 4 to the log base 4 of 5 times 2x minus 3. Speed it up slightly. 3x plus 6 over here is equal to 10x minus 15. Distributive property. Switch x's to the left, numbers to the right. We're getting a negative 7x, negative 21, minus 6, 15, 6 be 21, minus 10x, minus 10 and negative 7x, divided by negative 7 comes out an even whole number of 3, which of course only goes there and makes it positive, so it's legal. Let's see if that's in the back. If I blew that one. 54. I think I got it. See it, 54, 3. All right, well, I hope this helps any of y'all. Need more examples worked. We'll be getting the test out today. And we'll end the meeting.